Hey, looks like it's time for the weekly competition. All right, let's see here. Code. Oh, I should do this first. Rank transform an array. Given an array of integers, replace each element with its rank. The rank represents how large the element is. The rank has the following rules. The rank is an integer starting from 1. The larger the element, the larger the rank. Are there allowed to be duplicates? Some elements share the same rank. Well, I better hurry, huh? S equals set of ARR, S equals sorted set of ARR. Ranks equals value, comma, index plus 1 for I, comma, v in enumerate S. Return ranks of I for I and AR, right? Okay. Yeah, I should have already done that, sorry. Okay, let's see here. Okay, problems. Oh, yeah, I really should get some water. Where's contest? Contest is what I meant. Why'd I click the wrong thing? Okay, register. Register. I need water. This is a bad idea. Okay, let's see. Number of elapsed seconds between 2 times. You're given 2 valid times, start time and end time, each represented as a string in the format hour, minute, second. Return the number of seconds that have elapsed from start time to end time, inclusive of both endpoints. End time is not earlier than start time. All right. Converter of string is going to be xves equals s dot split. Then I need this to be integers int of I for I in s dot split, and then return what? Just I don't know, excess of 0 of 60 times 60 plus excess of 1. Good if I knew how to code. Okay, return C of end time minus C of start time. Okay, 25, 1504, 25, 1504, and submit. Okay, water. I'm getting water. All right, I got water and I got started. Okay, so let's take a look here. Wait, where's my okay? Minimal top. I need more water. Minimal total cost to process all elements. You're given an integer array. It is recording, right? Yes. You're given an integer array nums and an integer k. Initially, you have k units of resources. You must process the elements of nums from left to right. Okay. To process the ith element, you need nums I resources. If your available resources is less than nums I, you may perform an operation that increases your available resources by k. The value of k is fixed and does not change throughout the process. Okay. The first such operation incurs a cost of 1, the second incurs a cost of 2, and so on. After processing the ith element, your available resources decreases by nums I. Return an integer denoting the minimum total cost required to process all elements. Since the answer may be very large, return it modulo 10 to the 9th plus 7. 10 to the 5th, 10 to the 9th. Okay, and then k can be very, very small. Okay. Initially, you have k units of resources. Increases your available resources by k. After your available resources decreases by nums. Okay. S equals sum of nums. And then okay, I'm trying to think here. I feel like it's going to be like one less than what it needs to be. But if it's exact, then that's going to be, I want a ceiling function basically, right? It can be 1, but it can't be 1 with a remainder of 1. Okay. Needed k equals s divided by k. Now that's integer division. So if s mod k, then needed k plus equals 1 plus equals 1. And then needed k minus equals 1. Could it be 0? No, there's always at least 1. Yeah. Okay. And then it's simply going to be, are we going to get an overflow? Not with these ranges. We'll test it. Fine, I'll test it. Okay, modulo equals 10 to the 9th plus 7, right? 10 to the 9th plus 7. Value equals needed k plus 1 times needed k divided by 2. And what's the biggest that could be? 10 to the 9th. Come on. 10 to the 9th. So v times v plus 1. It's fine. All right. Return v mod modulo. Yeah. So 3, 15, 0. 3, 15, 0. Looks good to me. Okay, accepted. Sweet. Next problem. Create a grid with exactly k paths. Part 1. Oh, God. Oh, God. That sounds alarming. Okay. Construct any m by n grid consisting only of the characters period and pound, where period represents a free cell and pound represents an obstacle cell. A valid path is a sequence of free cells that starts at the top left and ends at the bottom right. Moves only right, down, right, or down. Oh, only right or down. Okay, got it. Return any grid such that there is exactly k paths from the top left cell to the bottom right cell. If no such grid exists, return an empty array. Shit. If it was create grid with exactly, or at least k paths, well, no, that wouldn't work. Then it could be all periods. How small can it be? 10 by 10. 10 by 10 is still a fucking 100. Shit. number of paths going through a specific cell, that we could figure out, right? And so if you just block that one cell, yeah, but it doesn't know the downstream way. Well, they all end at the same place. So if it went through, yeah, but if we get rid of multiple of them, they don't stack. It blocks everything downstream. You can't backtrack. That's what saves you. You cannot backtrack. All right. Can one cell affect another cell? That's the question. So every cell starts here, right? That would get rid of it. And what is K? What is K? Exactly K valid paths. Oh shit, K is tiny. It's tiny. All right, okay. That might be our saving grace. Is the next problem the same problem, just... No, it's not the same problem. Interesting. Okay. Are there two more? No. All right. Let's just use recursion. I think that this will work. So paths equals for I in range M. Is that the first one? If M is 2, it's like the row, right? Okay. For J in range M. Would we memoize? I don't think so, no. If we remove multiple things, though, it's going to change the downstream. Right? Is there a trick? Look at this. It wants K equals 2, right? So we open this. Boom, boom. And each one of these adds a new direction. Maybe we can always start with this being the initial path and then start adding these. That work? I don't know how that's going to work with different, grid shapes. Well, if it's wide enough, this could work. And if it's not wide enough, then we could do a permutation. Okay. I think this will work. Oh my God. This is going to be the worst solution in the history of mankind. There's always a way to have one path. I feel like that is a special case. If K equals 1, initial grid equals for I in range n, for j in range m, and then for I in range n, initial grid initial grid of 0, comma I equals period, allowing traversal in that direction. And then j in range m. Yes. If k equals 1, then return initial grid. Gee, I don't want to keep typing that. No, let's do gr. Gr equals initial grid. Okay. Now, if m equals 1 or n equals 1, then return an empty array. There's no way to have alternate paths. So now, if min of m comma n is greater than 1, and well, we know that's the case. If max of m comma n is greater than or equal to k. Okay, how big can k be? K can only go up to 4. Then we can simply choose the dimension that's the largest, and we add an extra path like this. Boom. So there's a second row here. Okay. Let's go if m is greater than or equal to k, then for I in range k, m is which one? M is the first one. So that would be like this, but lengthwise. So I'm going to make a damn mistake. Okay. Open extra paths like this. Initial grid of so it's through k. So if k is 1, then this would be 0, right? Which would be the last one. So yeah, 0, -1, minus, I'm gonna have to do it like that. That's stupid. -1 minus k. Not minus k, minus I. It goes like that. And that opens the extra paths. Then return the initial grid. Okay, the biggest it could possibly be is 16 by 16. in any other case. So if n is greater than or equal to k, well, no. We know that it is. Is greater than or equal to k. Oh shit. No. This is wrong. This is wrong. Here, let's focus on this case here. And then I can fix the one above. -1 minus I. This is incorrect. Okay. So we're saying the bottom row, we don't want the bottom row. We want the first row, or well, the second row. This one here. This is the row that we want. Okay, and then 0 is going to be -1 minus I. So -1, and if it's 2, then it'll be 1, and that would make it this one, and that opens the redundant path there. That is correct. And this is probably exactly the same. So it's going to be, imagine it's just these two. This is the ending spot. This is blowing my mind. Is that actually what I wanted on the other one? No, because the initial path is like this. So you're only opening one extra path. Okay, yeah, this should work. This should work. And now it is time for some serious bullshit. Okay. How are we going to do this? Well, we're going to have to create a permutation of every single one of these combinations, and then we're going to have to go through it and see how many paths there are. And we know that it is less than 16 different cells, right? We know that. Yippee-ki-yay. Okay. Bit mask equals 1, and this is so dumb. This is so dumb. Well, I mean, the alternative is not doing the problem, so we're brute forcing it. Yeah. So mapping equals like that. And we're going to say mapping of bit mask equals I comma j, right? Yes, that is correct. And bit mask times equals 2. Okay, so assert mapping of 1 equals 0, 0, and assert mapping of bitmap divided by 2 equals m minus 1, comma n minus 1. Yes. So, okay. So valid key equals bitmap bit mask, excuse me, -1. And then no, -1, -1. Does that make sense? Yes, that makes sense. Okay, bit mask divided by 2. In other words, the last bit. And then we will just say assert valid key dot bit count equals m times n minus 2, right? Then do all combinations. For all combinations in range, bit mask, and then if bit mask and valid key equals bit mask. In other words, if the start and end are clear, then we are going to generate a grid. Grid to try equals, yes. Okay. If something else, period, right? So if what? If all combinations, let's just make this I. What the hell? I invalid key equals I. If I nope, this doesn't work at all. Period. Might have worked if I went the other direction. Now for k comma p1 p2 in mapping.items if k and I, wait, we can't do k, we can't do k, k1, if k1 and I, then grid to try of p1 comma p2 equals that, right? Okay. So let's see. Def num paths of grid comma I comma j. Yes. So if I equals -1 and j equals -1, then return 1. If gr of ij equals that, then return 0. If I equals 0 or j equals 0, then return 0. and it can go down or to the right. Otherwise, return number of paths, gr, comma, I plus 1. Okay. So we are going to brute force this. I did that wrong. Sorry. Okay. Now the trick is going to be calculating. So if this specific grid has the right number of paths, if k equals number of paths, gr, I, well, hold on. The last one is -1, right? Yes. -1. Well, it's just going to be 0, comma, minus 0 minus m, 0 minus n. Okay, and then we will return grid to try. Otherwise, we return an empty array. Run. Closing parentheses does not match opening parentheses. Yeah, okay. Looks like it matches to me. Yeah, I figured it out. Okay. List assignment index out of range. Create grid. But didn't we already verify? No, we didn't. Well, that was dumb. Okay, so period, period, period. Aha, okay. So I correctly created that one. That was my case, this one right here. And then number 2. Shit. 1, 2, 3, 4. Okay, case 3. Right, we found none of them. So let's see what this is returning. Result equals that. Print grid to try. Print result. Let's see what it does. Invalid syntax. If k equals result. I'm not overwriting k somewhere, am I? No, I don't think so. Okay, so what is this? Is this a 3x3? Yes, it is. This is a 3x3. It returns 1 for everything. Are we not adding? 0, 1, Um, what about the case where everything is blank? Why is there something here for the very first case? Yeah, so I should be equal to 0, right? What? What in the hell? Okay. There still should have been a 0, though. Why was there no 0? P1, P2. If K1 and I, but I should be 0 at first, right? Print I. Zero. Okay, that's right. 1. 1 doesn't work because that blocks it. Exactly. Okay. But why did we print 1? Oh, we didn't. This is this one. Okay. 4. 4 is what we wanted. No, it's still giving us 1 every time. Okay, so this should be starting at -1, 2, 3, right? -1, 2, 3. Zero. This is just downright bizarre. Wait, what is GR? Oh, God damn it. Copy. Copy. Thank you. Dumbest mistakes, I swear to God. Okay, print and submit. Shit. Okay. Use test case. How did any of them pass? Well, maybe none of them passed. Then why was that the one to fail? All right. Is that right? Okay. Run it locally. All right, that's right. All right. Okay, so it wanted a grid of 3, right? Are you saying that mine is not valid? One. Oh, no. Oh, no. Yes. We started at the wrong side. Okay, this is the case where it's going down, right? Yes. And this is right. This is not right. That should fix that. Let's see. Now what? Assertion error. This should be the very last one, right? I, comma, J, N, M. List index out of range where P1, comma, P2. Please work. Oh, thank God. All right. Maximum consistent columns in grid. You're given a two-dimensional integer array grid of size m by n and an integer limit. You may remove 0 or more columns from the grid, but at least one column must remain. The relative order of the remaining columns must be preserved. That's how I interpret remove, but that's fine. A grid is called consistent if for every row I and for every pair of adjacent remaining columns A and B, with A is less than B, the following holds. The absolute value of grid I of B minus grid I of A is lesser than or equal to limit. Return the maximum number of columns that can remain such that the resulting grid is consistent. Let's read that again. Okay, the relative order of the remaining columns must. A is less than B. Adjacent columns. A is less than B. So after you removed it, it's basically column 0 and, or column A and column A plus 1, basically. And then it's the absolute value has to be lesser than the limit. Return the maximum number of columns. So basically, I'm looking at, you know, which column has to be removed. Wow, why are these constraints so low? I guess grid I of j. No, that seems really low. Do they want me to brute force it? I mean, basically, you just couldn't have specific columns. It's like, okay, but, well, no, there's still a choice. There's still a choice. Do we have column I or don't we? Right? Because it might make more sense to not have column I. And then from there, it's like, what is the next acceptable? Yeah. Okay. Illegal pairings equals, yes, set. Whatever set, man. All right. For I in range length grid. I don't really think that it matters. 250 times 250 times 250. So 15 million. Yeah, that's fine. For j in range length grid 0. For k in range j plus 1 comma length grid 0. And then it simply, if the absolute value of grid I of j minus grid I of k is greater than, it's going to be lesser than or equal to. So if it's greater than limit, then illegal pairings, and that is way too long of a name. IP dot add j comma k, right? And then, you know, maybe we want legal pairings. Maybe that is what we want. So it's just there's certain columns that can't be adjacent. It's as simple as that. And then we're going to say def max columns from position I. So we are saying, given that column I will be included, what is the, no. Given that column I will, yeah. Column I is a given. How many more can we get? And we're going to say LRU cache none, and hopefully we don't have an out of memory bullshit. Okay, so max value equals 1 because we have I. And then we're going to look for valid pairings. And I don't think that we should calculate that every time. We're going to say legal next column equals for I in range length grid of 0. Yeah, for j in range I plus 1, comma, length of grid 0. Like that. And then, yes, what goes here? Well, just j. J goes there. But it only goes there if, what's the bigger one? K is the bigger, so the second one is the bigger one. If I comma j not in illegal pairings, right? Okay, and then for j in legal next column of I, max value equals max value, comma, MC of j. Like that. What do you think of that? Yeah, and then just return max of MC of I for I in range length grid 0. Probably should have defined a constant for the number of columns, but whatever. Okay, object is not subscriptable. M's not subscript. Did I do that anywhere else? Not supported between none types and int. C and return max value. That was a weird mistake to make. Okay, 1, 2, 1, 2, 1, 2, 2, 1, 2, 2, 1. There's exactly one column, so yeah. Okay, something is breaking here, so let's see. Print illegal pairings. Illegal pairings is 0, 1, and 1, 2. How can it be 0, 1, and 1, 2? That doesn't even make sense. There's not that many columns. J, comma, K. This is case 2, right? Oh, there are 3 columns. 0, 1, and 1, 2. Okay, maybe that's true, but 0, 2 is not in there, so why didn't you construct it? Legal next column, run. It's right there. This is correct. We can add column 2, 0, 1, 2. So it comes in here. Our existing value. All right. 2, 2, 1, 2, 2, 1. Did I get rid of the print? I think that I did, and submit. And it's accepted. And that is another completed weekly contest. Woohoo! Man, that sucked. All right, see.